on number 41 now. Solve by substitution. And what that means by substitution is we've got x plus y equals 4 and y equals 2x plus 1. Now the only time I would use substitution is if I was given an equation like this where I have one of the equations solved for one of the variables. Like here, you got y equals 2x plus 1. So what am I going to do? I'm going to take that equation and I'm going to substitute it into this equation. And there, I'm going to plug expression here, equation, into this one. So as I substitute that in, I'm going to go x plus, now what's y? Y is 2x plus 1. So I'm going to plug in 2x plus 1 in for y. That's what it means by substitution. Then x plus 2x is 3x plus 1 equals 4. Subtract 1 from both sides. We get 3x equals 3. Divide by 3. And x equals 1. Now once we get that, then what we're going to do is we're going to take that x equal 1 and we're going to substitute that answer into this equation. Y equals 2 times, what did we say x was? 1 plus 1. And then we get y equals 2 plus 1, so y equals 3. And we write it as an ordered pair, so it would be x is 1, y is 3. So the ordered pair would be 1, 3. Remember, when you do a substitution, it's kind of like when you're substituting into a game. When you substitute one player for another, both players don't stay on the court at the same time. They have to switch positions. So now here, same thing here. When I substitute 2x plus 1 in for this y, the y goes away. It goes to the bench because I'm substituting 2x plus 1 in for it. Here's another substitution problem. Now, of course, this one is not solved for one of its variables. So I probably would use elimination, but since it says to use substitution, we'll go ahead and use substitution. First things first, we need to solve one of the equations for one of the variables. I'm going to go ahead and solve this one for y. You get y equals negative x plus 6. You may say, well, why did you solve for y? It really doesn't matter. I could have solved for x either way. So what I'm going to do is I'm going to take this answer right here, negative x plus 6, which I know is what? Y. I'm going to go over to this equation and I'm going to substitute that in. So I get x plus a what? Negative x plus 6 equals 8. So I substitute negative x plus 6 in for the y value. When I do that, well, what's x plus a negative x? Well, x plus negative x is 0. So that zeroes out. And so I'm left with 6 equal to 8. Can 6 equal to 8? No. So what does that tell me? That there's no solution to this problem. And the reason why is, if we actually solve this one for y, watch what we get. Y equals negative x plus 8. What does that tell me? Well, that's a negative 1 slope. That's a negative 1 slope. These two lines are parallel. Remember, we've seen that before. Parallel lines have no, or their slopes are the same, and they have no solution because they do not intersect. This was elimination. Process of elimination basically eliminates one of the variables by adding the two equations together. Now sometimes you have to do a little extra work to get rid of the other equation, but in this case we don't. Because what we want to look at is we want one of the variables to be opposites of one another. Here I have a positive s and a negative s. So I've already got my opposites in place. So all I have to do is add the two equations together. R plus r is 2r, and if you don't know that, put a 1 in front of the r's. 1 plus 1 is 2. These zero out, and 10 minus 4 is 6. The whole process is to eliminate one of the variables so you can solve for it and then solve for the other one after that. Divide by 2, so r equals 3. You're not done yet because you've got to solve for both variables. Then I take this and I substitute it into one of the original equations. R plus s equals negative 4. I'll go ahead and use that one since it's the top one. I'll plug in 3 for r. You might say, well, isn't that substitution? Well, yeah, once you, the initial elimination method is right here. And then from there, you get that answer and you got to substitute. So you still have a little bit of substitution that you have to do. Subtract 3 from both sides. You get s equal to a negative 7. So therefore, now, when you put these in this ordered pair, it goes in alphabetical order. What comes first, R or S? Well, R does, so it would be 3, negative 7. Again, they want us to do elimination on number 44, so we got x plus 2y equals 3, and x minus y equals 6. Now, I line them up like this because I want to compare the variables. I have x's there, and I have y's right here. Now, I want to eliminate one of them. Well, are they opposites? Now, some of you might say, well, the y's are opposites. Yeah, they have opposite signs. They have one's a negative, one's a positive, but they're not total opposites because this is a positive 2 and this is a negative 1. So they're not opposites. But to be honest with you, I would probably eliminate the y's. But before I can eliminate them, I have to make them exactly opposite. Meaning, if this is a positive 2, I need to make this one a negative 2. And to do that, I need to multiply that negative 1 by 2. But I can't just multiply the y by 2. I have to multiply the whole equation or it changes the equation. Alright? For example, if I have 2 equals 2 over here, if I add 3 to this side and I add 3 to this side, I still got 5 equals 5. So it's still equal. So if I'm going to change one thing in an equation, I got to change everything by that same amount so it doesn't change the value. So we got 2 times x is 2x, 2 times the negative y is negative 2y, and 2 times 6 is 12. So I have to multiply that 2 all the way through there. Then what I'm going to do is I'm going to take this original top equation. I'm not going to do anything with it other than rewrite it down here. So I get x plus 2y equals 3. Now I have opposites. So I'm going to go ahead and add these two equations together. 2x plus 1x is 3x. These two zero out. 12 plus 3 is 15. Divide by 3 and I get x equal to 5. And what am I going to do with that? Well, once I get x equal 5, then I'm going to go back to one of my original equations. Doesn't matter which one. I'll take the top one again here. X plus 2y equals 3. Substitute 5 in for x. And then I solve for y. Subtract 5. It gives me 2y equal to a negative 2. Divide by 2 and y equals a negative 1. So my answer would be 5, negative 1. One more question using elimination method. We got 4x plus 5y equals 6. Negative 8x minus 10y equals a negative 12. Again, I need to make them opposites. I'm going to go ahead and do my x's this time. I want these two to be opposites. Well, this is a negative 8, this is a positive 4. So what do I need to do to that 4? So what am I going to multiply times the 4 to get a negative 8? I would get multiplied by negative 2, but I don't want a negative 8, do I? I want the opposite. So I want a positive 8. So I'm going to multiply that by a positive 2 to keep that to be a positive. So when I distribute that, I get 8x, 10y positive, and a positive 12. Now it looks very similar to the second equation, doesn't it? Well, let's see what happens when we add that new first equation times the second equation. Negative 8x plus 8x, 0. Negative 10y plus 10y is 0. Now, everything went away on the left side. Or did it? Yeah, it did, but what do we put? A 0. It is not nothing. It's not like everything disappeared. 0 is a number, so make sure you put 0. 12 minus 12 is what? 0. Now, does 0 equal 0? Yes. So this is infinitely many solutions. Okay, it has infinitely many. That means that they're exactly the same line. They just were written differently, had factors taken out of them and different things. And so their looks were different, but the actual line itself is the exact same line. If we graphed both of those on the dill, we would have the same exact line.